The different species of hydrogen are atomic hydrogen, molecular hydrogen, hydrogen anion, hydrogen cation, and hydrogen in molecules or compounds, such as water. This section will answer most of the common questions that either you have, or that you will get, from those you talk with about hydrogen. Many people get confused from the very beginning when they hear or read about hydrogen research, because there are 5 different main ways that hydrogen is found, as well as 3 different isotopes. Of the 5 different forms of hydrogen, 2 are in the molecular forms, in which the hydrogen atom combines with other atoms to form a molecule, which is the most common way hydrogen exists on Earth. The differences are all about the electrons, either in the number of them or how they are shared. It's important to reiterate how essential this information is. Let's start with elemental hydrogen, or atomic hydrogen. Atomic hydrogen, or the hydrogen atom, was the first element in existence and can be considered the ancestor of all the elements. Accordingly, it is the first element on the periodic table of elements. We remember from the last section that atoms in their elemental form have an equal number of protons as is their atomic number, and they have an equal number of electrons as protons. Hydrogen has the atomic number of 1, meaning it has 1 proton, and therefore, 1 electron, which means it will be neutral, that is, it won't have a charge, and is not an ion, neither a cation nor an anion. Atomic hydrogen is represented here with its single proton and single electron. Unlike all other elements, atomic hydrogen has no neutrons. Well, some isotopes of hydrogen do have neutrons, but the hydrogen we are talking about does not. We discuss the isotopes of hydrogen in Level 2 courses since it has important implications. Since electrons don't significantly contribute to the mass of an atom, the mass of the hydrogen atom is essentially that of its single proton. This means that it weighs about 1 gram per mole of hydrogen atoms, that is, if you had 1 mole of hydrogen atoms, it would weigh 1 gram. Now let's talk about the 2 hydrogen ions, the hydrogen anion and the hydrogen cation. Remember, an ion is simply something that is not neutral, but has a net negative or net positive charge. Atomic hydrogen is neutral, but if we add an extra electron, then we get a negative hydrogen ion, called the hydrogen anion. If we remove an electron from atomic hydrogen, then we only have the proton left, which makes a positive hydrogen ion, called the hydrogen cation. Molecular hydrogen has the chemical formula written as H2. Molecular hydrogen is formed when 2 hydrogen atoms are covalently bonded together with a nonpolar covalent bond, so equal electron sharing. They have a linear formation as shown. Because there are 2 hydrogen atoms, we call this diatomic hydrogen. Because the hydrogen atoms are covalently bonded together, they form a molecule. So, H2 is also referred to as molecular hydrogen. Molecular hydrogen is sometimes also called dihydrogen, diatomic hydrogen, H2, hydrogen gas, or simply hydrogen. The hydrogen molecule contains 2 protons and 2 electrons, making it a neutrally charged molecule. It is a colorless, odorless, tasteless, non-metallic, highly flammable gas. It is a neutral molecule, so has no charge, and it is quite stable, unless you ignite it in the presence of oxygen. If you do, then it explosively combines with oxygen to form water as shown in the equation here. So, yes, H2 gas is explosive. That is why it is a great alternative energy source. In fact, it has about 3 times more energy by weight than gasoline. However, it is only explosive above 4 to 10% and below a 75% concentration in air. Furthermore, when it is dissolved in water, it is not explosive at all. Just like gunpowder is explosive, but not when it is dissolved in water. So, there is no risk of explosion, at least with hydrogen water. That molecular hydrogen does not influence the pH. Remember, the concentration of hydrogen ions, the cation, is what pH means. So, when H2 dissolves in water, it just gets surrounded by water molecules, but it does not break apart. That is, it does not dissociate into hydrogen atoms or hydrogen ions. In other words, the dissociation of molecular hydrogen breaking into cations and anions or even hydrogen atoms alone does not happen at all. This includes even in the low acidic pH of the stomach. The hydrogen molecule stays together. The last form of hydrogen is by far the most common, which is another molecular form, but this time forming compounds. We remember that a compound is simply when an atom combines with atoms of a different element, such as water, H2O, which is composed of hydrogen and oxygen atoms. Hydrogen can combine with nearly all the elements to form different compounds. You'll remember that the molecules and compounds of glucose, C6H12O6, and hydrogen peroxide, H2O2, both contain hydrogen. In fact, most biological compounds contain hydrogen, carbon, and oxygen, such as those mentioned above, as well as fats, proteins, nutraceuticals, phytochemicals, hydrochloric acid, ammonia, etc. The hydrogen is chemically bonded to the other atoms via polar or nonpolar covalent bonds.